Hello viewer, welcome to the world of object-oriented programming or OOP. Up until now, we've been writing code like a recipe, step-by-step instructions. OOP is different. It's about modeling the real world. Think of a class as a blueprint for a house. The blueprint isn't the house itself. You can't live in it. But you can use that one blueprint to build infinite actual houses. Those actual houses are called objects. Now let's create a car class. Inside a class, we write functions, but here we call them methods. And you'll see this word self everywhere. Self simply means this exact object right here. If one car is red and another is blue, self helps Python know which specific car we're talking about. Every time we create a new object, we need to set it up. That's the job of the __init__ method. It runs automatically the moment an object is created. Think of it like a constructor on a factory line. This is where we give each car its brand, color, and anything else it needs. Now let's bring our blueprint to life. We create objects by calling the class like a function. So car, Toyota, red, builds one car, and car, Ford, blue, builds another. They use the same blueprint, but each object carries its own unique data. We know self.brand is unique to each car. That is an instance variable. But what if we want a variable that is shared by all cars, like the number of wheels? That is a class variable. If I change a class variable, it updates for every single object created from that class. Use these for constants shared by everyone. Now let's talk about methods. The most common type is the instance method. These take self as the first parameter. They can read and modify the specific data of the object calling them. For example, definite drive, self allows a specific car to move. Sometimes you need a method that deals with the factory, the class, not a specific car. These are class methods, marked with the @class method decorator. Instead of self, they take CLS, class, as the first parameter. A common use? Creating alternative constructors, like loading a user from a string instead of raw data. Finally, static methods. These don't care about the object, self, or the class, CLS. They're just regular functions that logically belong inside the class for organization, like a utility function. We use @static method. They cannot modify object or class state. Inheritance in Python works just like a family tree. A parent class passes its features down to its children, and those children can pass them further down. A vehicle can become a car, a truck, or a motorcycle, and a car can become a sports car or an electric car. The idea is simple. Features flow downward, so we don't have to rewrite the same code again. Inheritance lets one class borrow everything from another. Here, dog inherits from animal. Even though dog doesn't define the eat method, it still gets to use it for free. That's one of the biggest advantages of OOP. Reuse what already works and avoid repeating the same code over and over. In Python, a child class can replace or override a parent's method with its own version. A regular car might start with an engine roar, while an electric car starts with a quiet hum. And when the child still wants to use part of the parent's behavior, it can call super. Think of super as a bridge connecting the child back to the parent's original method. Encapsulation keeping secrets. Imagine if anyone could reach into your car's engine and cut the brake lines. That's dangerous. In code, we want to protect sensitive data. This is encapsulation. In Python, we use underscores. One __ many means please don't touch. Two underscores __ password makes it private. Python actually makes it very hard to access this from outside the class. Getters and setters. Once the data is hidden, we still need a safe way to use it. That's where getters and setters come in. They're the gatekeepers. A getter lets us read the value, and a setter lets us update it, but with rules. For example, A setter for age can check that the number is actually valid before allowing it. That way, your program refuses bad data before it becomes a problem. Polymorphism simply means many forms. It allows objects of different classes to respond to the same command in their own unique way. If I loop through a list of animals and call.speak, on each one, a dog barks, a cat meows, and a bird chirps. I don't need to check which animal is which. Each object knows how to behave. This flexibility is powerful when building large systems. Magic methods, dunder methods. Python has special methods called magic methods or dunder methods. You've already seen one, init. But there are many more. For example, str controls what you see when you print an object, and add lets your objects use the plus operator. By defining these, your custom classes start behaving like built-in Python types, clean, readable, and beautifully Pythonic.